is GUO CHENGXI 12 years old primary 6 from Qifa Primary School. For this lesson, we'll be proceeding on from the previous lessons of physical chemistry. For this lesson of physical chemistry, we'll be mainly explaining about this question and some things about the Raoult's law. So, for the Raoult's law, what is it about? So, the Raoult's law is about how the pressure from the vapor, the solvent vapor, or else the pressure from the gas state of the solvent. So the formula is the pressure of the solvent vapor in the solution is equals to chi, no matter how much it looks like X, it is still chi and it's solvent. Then after that, it will be times the pressure of the pure solvent vapor. So the difference between these two is that for this part over here is the pressure of the solvent vapor above the solution, while for this part it's just the pressure of the pure solvent vapor. Okay, so over here for this chi solvent, if you add it all with chi solute, it will become 1 because they're over here the different molecules. So here, so another way to write this is 1 minus chi solute, while here is still pressure of pure solvent vapor. Okay, so this will become the pressure of the pure solvent vapor minus chi of solute times the pressure of the pure solvent vapor. Okay, so this is what we'll get. So in other words, chi solute times the pure pressure, the pressure of the pure solvent vapor is equals to the pressure of the pure solvent vapor. So it is the pressure of the solvent vapor above the solution. It is subtracted from the pressure of the pure solvent. Okay, so despite the fact that one may be solution and one may be solvent, both of them are still talking about the pressure of the solvent vapor. It is just that the pressure of for this part, it is just that the solvent vapor is from pure solvent vapor, while for this part over here, it is from the molecules from the solution. So it is just the solvent above the solvent vapor above the solution. So now that I have roughly talked about Raoult's law, so we'll be moving on with next. So first we'll have this question. So this question over here, let's see, the first phrase is already ethylene glycol. So what is ethylene glycol? Ethylene glycol, in short form, it is EG. So we're going to read this question first, but before that, we're going to explain about why I wrote for this part. So for this part over here, what we have over here is the decrease in pressure between the pressure of the pure solvent vapor and the pressure of the solvent vapor above the solution. So now that we have have explained for that, and we're going to take a look at this question first. So as you can see here, we have the first phrase already is ethylene glycol. So ethylene glycol, short form, which is EG, and these two are its chemical functions. So ethylene glycol, if you draw the structure, it will be like this, okay? Although there are other ways to like draw this structure, but this is one of the ways to draw the structures, okay? So as you can see, he see two of them, and then after that O2, then H6. So there are other ways to draw them, and like you can use like this, which we are not going to specify over here, so I'm just going to erase it. So this is the main the structure for the ethylene glycol. So factors for the ethylene glycol is that ethylene glycol is a syrupy, odorless and colorless mixture. While for this is a major, as you can see here, the sentence over here is that it is a major ingredient in commercial automotive antifreeze, increases boiling point of radiator fluid by lowering its water pressure. So before that, it's a major ingredient in commercial automotive antifreeze. So for this part, because the ethylene glycol has a way lower freezing point than water, so that's why it will be used in like commercial automotive antifreeze and others. Well, ethylene glycol, on the other hand, it is used in like a lot of materials. You can find it almost everywhere. It's like it can be used for like carpets, it can be used for the bathtubs and all those, okay? So there's like a lot of uses for it. So for this part, for boiling, now moving on to the next part, increases boiling point of radiator by lowering its vapor pressure. Is that so? The boiling point, what is boiling point? You may think that it is just has like where water reaches 100 degrees and all, but what does water reaching 100 degrees and all is supposed to mean? Is it just because it makes bubble? But why does it make bubbles? Well, it is because that the pressure from the vapor, from the solvent vapor, is equal to the pressure from the atmosphere. Atmosphere. So when they are equal, that is the boiling temperature. So by lowering it, there won't be this. It's like the atmospheric pressure will be bigger than the vapor pressure, causing it unable to boil. So normally, like when you see the oil boil and all it's like you see bubbles, because it's like there's the vapor pressure and then there is the atmospheric pressure, which is equal, causing the bubbles. Well, over here for this part, now that we have said it, so ethylene glycol, why would we need it? Well, ethylene glycol is used in a lot of things that are like that we probably have in our lives. So it's like in our daily life and all those. So over here for this part, and now moving on, we have at 100 degrees the vapor pressure of pure water is 760. Here, and then after that, here is mercury. So Hg is basically mercury. So over here, you're calculating it by for the mercury. So for this part over here, as you can tell, how you most probably have learned this before, but pure water boils at 100 degrees, right? So over here for this part, it is basically when the vapor pressure of the pure water and the pressure from the atmosphere is equal. So now what we have to do here is to calculate the vapor pressure of an aqueous solution. And so aqueous solution means that we have studied in past lessons that H2O is a solvent with 30.2% and ethylene glycol by mass. Basically by mass, as the pure water is going to be like 79.8% by mass, okay? So over here, a concentration commonly used in climates that do not get extremely cold in winter. So over here, her reason to use ethylene glycol is like another use is to so that you don't get extremely cold during winter, because okay, so we'll be moving on with this question. So for this question, although I explained it earlier, but for this part over here, since it's an aqueous solution, so the solvent is H2O, and then after that we know how much by mass we know how much of it is H2O and ethylene glycol. So through this information, we can tell that there is 69.8% of the solution being H2O, while 30.2% being ethylene glycol. So for this part, we have two different methods over here. So method 1 we have. So method 1 will first find the number of moles for H2O. So over here for this part, first of all, you may be wondering what is the total. How are you supposed to do it if you don't even know the total? Well, over here we're going to assume that it is 1000, and I'll tell you why later. So for this part, if the total is 1000, that means that what we'll have over here is 698. But for the denominator, it's going to be the molar mass, which is 18H1. So H molar mass is 1, and then the oxygen molar mass is 16. So you put them together 18, because there are 2H. Then after that, now you have chi. Oh, whoops! I forgot the calculator. So sorry. Give me a sec. So I'm just going to calculate this. It is 38.8. So apparently here this is 3 significant figures. So for this whole question, for these two methods, we are going to be using 3 significant figures. So for this part, now we have chi H2O. Okay. So chi H2O. Also, what does chi mean? So chi is the mole fraction. That's why over here for this part we have to have the 1 minus chi. Okay. So for this part over here, chi, no matter which way you deal with it, you still have to calculate the chi for the solvent or the solute, okay? Either ways, even for solvent, even for solute, you still have to find the chi. So for this part over here, what we'll have is 38.8 over, so it's the moles of H2O over the total moles. But the total you also have to find for ethylene glycol. So number of moles of C2H6O2, it will be, for this part what you have, since the percentage is 30.2, it will be 302 since it's going to be 1000. So over here for this part, the only reason why we can assume that the total is 1000 is because that afterwards we'll change it into a fraction. So once you change it into a fraction, they'll get cancelled. So that's why we just do this to make it simpler. So it'll be over 62, and that is the C2H6O2's molar mass. And then what you have is so over here we need 3 significant figures. So 4.87. 3 significant figures, basically. So now you have to add on was 4.87. So now you have to divide 38.8 by 38.8, adding with 4.87, which you're going to get 0.888. So the reason why there are 3 here is because there are once again 3 significant figures and you cannot round up, so it's going to stay as 888. Okay, so now that we have gotten this part, so for the chi's, now how we can, since you're calculating the vapor pressure of the solution, and so it is basically pressure of the vapor pressure above the solution. In this case, it is water vapor. So over here, the solution for this part is the aqueous solution containing this 30.2% of ethylene glycol, which here for this part you have. So the first method is basically to use the X solvent, the chi solvent, in times the pressure of pure solvent. So the pressure of the pure solvent is already stated at first, which is 760 mercury high. So that is the unit for it. Okay, so you have to calculate this. Okay, so it will be so you can see the chi solvent. The chi solvent you have 0.888 times the 760. So when you times these two together, you get so technically it will be 675 since it is 3 significant figures. Okay. Because even if it is 674.88, you still have to write it in 3 significant figures. Okay. Alright, so for this part, we have now calculated the her vapor pressure for the above the solution. Okay, so I forgot to write the unit, which is give me a sec. Mercury height. So for this part it is 675 mercury height, and now we're going to move on with the second method. So for method 2, so we have method 2 over here. So for method 1, we were using the one above over here, the Chi solvent times the pressure of the pure solvent vapor. But for this time, we'll be using the below part over here. Okay. So method 2 will have to find the number of moles of Eg. Well, we have already calculated, so I'm not going to calculate it again. So for this part, we're going to have 4.87. And then after that, now that we have this, we're going to have the Chi solute. So the Chi solute is basically here for this part, the Chi solute, Chi Eg, is 4.87 over the same thing as before. 38.8 plus 4.87, whereas you will get 0.1115. But 3 significant figures, so the 5 you have to round up, so it becomes 0.112. Okay, alright, so now that you've gotten this, we can move on with the next part, which is this part of our answer. So for this, we'll have, so the Chi solute, Chi Eg, E times the pressure of the pure solvent. It is equals to 0.112, as you can see here, times 760, because that's a pure solvent vapor. So over here you have so you supposedly have 85.12, but 3 significant figures, so it will be 85.1 over here. And now we're going to have the pressure of the pure solvent, solution, the pressure of the pure solvent to minus of this part, which will get the pressure of the solution, which is 760 minus 85.1, which will get, so if you calculate it, what you get here is 674.9, but since over here 3 significant figures, so we'll have to round up. So you'll get 675 mercury height, whereas you'll figure out that it is the same as the one that we get from method 1. Okay, so over here, although it is used for to cool down on the area, like for this, the ethylene glycol is used in a lot of cooling, heating systems, even in car fluids and all. They are used for refrigerators, they are used for antifreeze and all those. But if you feel like almost 1/3 of it was the ethylene glycol, the temperature, the vapor pressure, it only decreased by 85 mercury height. So over here, despite the fact that it will lower the vapor pressure, causing the boiling point to increase, but it doesn't really actually affect that much, because as you can see here, almost like 30% of it is already ethylene glycol. Yet not even 30% of this is still is that more than 70% of the solution. The temperature is still like this. Okay, so it's like there's not much temperature decrease from this. Okay, so you can take a quick look over here, and that'll be pretty much all for this lesson. So we mainly said about the formula for the Raoult's law. Then after that, we explain what ethylene glycol is and what it's used for and all. Then we use two methods to solve this question of calculating the vapor pressure from above the solution. Okay, so that'll be all for this lesson. Last but not least, thank you for your watching.